Hi everyone, welcome back to another practice question on complex numbers. This is taken from the SAJC 2019 Prelims Paper 1, question number 6. If you are ready, let's jump right in. The question wants us to express p in exponential form. So just a quick recap, you'll need two ingredients to express a complex number in the exponential form. The first ingredient will be the modulus. So the modulus of p is square root minus 1 square plus minus root 3 square, and this will give us a value of 2. Now the next ingredient is the argument. Now if you're not sure of how to get the argument, not to worry, we can represent this on the Argand diagram where p is in the third quadrant. The basic angle is tangent inverse root 3 over 1, and this gives us a value of pi over 3. Now always take the argument from the positive x-axis, so the argument is minus 2 pi over 3. Now take note that the argument cannot be more than pi, so that's why we are taking this in a clockwise direction from the x-axis to give us minus 2 pi over 3. So putting them together, the exponential form of p is 2e to the power of I multiplied by minus 2 pi over 3. In part 2, we want to find the two smallest positive whole number values of n, for which this expression is a purely imaginary number. Now, in such scenarios, let's always try to simplify the expression as much as we can so that we can make use of the argument to illustrate it as a purely imaginary number. So the conjugate of p power n over I p is equals to 2 power n e to the power of I positive 2n pi over 3 close the bracket over 2 e to the power of I open the bracket minus 2 pi over 3 plus pi over 2 close the bracket. Now I is illustrated by e to the power of I pi over 2. That's why you see a pi over 2 over here. Now simplifying and using your rules of indices, we will have 2 to the power of n minus 1 multiplied by e to the power of I 2n pi over 3 plus pi over 6. Now for this expression to be purely imaginary, it means that the complex number lies only on the y-axis, which is pi over 2 or minus pi over 2. But this also means that the possible arguments of this expression could be pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, so on and so forth. So what we can do is to illustrate this relationship by introducing 2k plus 1 pi over 2, where k is an integer. Now if we were to factorize pi over 2 from pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, so on and so forth, we will have the expression 1, 3, 5, 7, so on and so forth multiplied by pi over 2. So that's why we have 2k plus 1 over here. Now simplifying the expression, we will have 2n pi over 3 plus pi over 6 is equals to k pi plus pi over 2. Bringing pi over 6 to the right hand side of the equation, we have 2n pi over 3 equals to k pi plus pi over 3. Dividing both sides of the equation by pi over 3, we will have 2n equals to 3k plus 1, and n is equals to 3k plus 1 over 2. Now this is not the final answer, always answer to the requirements of the question. For the two smallest positive integer values of n, we will have k is equals to 1 and k is equals to 3. And this gives us a value of n equals to 2 and n is equals to 5. So by doing this, we are answering to the requirements of the question. Now moving on to 6 part B, without using the calculator, solve the simultaneous equation involving complex numbers z and w. We are going to express them in the form of x plus yi. Now before you jump in, make sure you can scan the question and plan in advance what you can do. So from the first statement, I can see that w can be isolated and be substituted into the second equation. So what we can do is to make W the subject, which is equals to Z plus 6 plus 7i. And we can substitute this in this equation. We will have 2, open bracket, Z plus 6 plus 7i, close the bracket, minus I multiplied by the conjugate of Z, minus 19 minus 3i equals to 0. Now, simplifying the expression, we will have 2Z plus 12 plus 14i minus I conjugate of Z, minus 19 minus 3i equals to 0. And by further simplifying the expression, we will have 2Z minus 7 plus 11i minus I multiplied by the conjugate of Z is equals to 0. Now, it is at this stage that we can introduce Z equals to X plus IY, because you realize in the statement over here that there is a Z and there's a Z conjugate. Alright, so what we can do is to substitute X plus IY into the expression and X minus IY accordingly as well. So 2, open the bracket, X plus IY, close the bracket, minus 7 plus 11i minus I multiplied by X minus IY, close the bracket, equals to 0. Now let's try to group all the real terms on one side and the imaginary terms on the other. We will then have 2x minus y plus 2y minus x multiplied by I equals to 7 minus 11i. The reason why we are doing this is so that we can compare the real and imaginary parts so that we can find the values of x plus y. So by comparing the real and imaginary parts, we will have 2x minus y equals to 7. Y is equals to 2x minus 7. Maybe we can put it as equation number 2 for this. And on the other side, 2y minus x equals to minus 11. So let's put this as equation number 3. By substituting equation 2 into 3, we will have 2 multiplied by 2x minus 7 minus x equals to minus 11. 4x minus 14 minus x equals to minus 11. We have x equals to 1, and finding the value of y, we will have minus 5. Now here we see that the complex number z is equals to 1 minus 5i. And by substituting this into w, w equals to 1 minus 5i plus 6 plus 7i, and this will give us 7 plus 2i. So there you have it. We have answered to the requirements of the question. Z is equals to 1 minus 5i, while W is equals to 7 plus 2i. Now I do hope you learned something from this video. If you like this video, do hit the subscribe button so that you can see more valuable content such as this. I'll see you in the next video. Thanks for watching.